Okay, we're talking about section 1.6. It's just a kind of a one-day shot on transformations. This is the stuff that you took 2 weeks learning last year, or maybe 3 weeks, and we're going to scrunch it down into one day, review it. You should be pretty easy stuff. All right, to begin with, this is the square root function. Do you remember that one? Remember that general picture? So if I move it to the right, that's or left, that's on the inside of the function. Like you'd have the square root, and then inside with the x, you could like change it. If you put something outside, it moves it up and down. Okay. All right. So that was square root. How about this guy? What's it? Absolute value. Okay. How about this one? It's a parabola, but it's called the x squared or quadratic function. Okay. And the last one's this one. That's the 1 over x one. Okay. And that's not in the right spot. It's supposed to be right there. Okay, so those are some of the main parent ones that you have to remember. Now, when you do something like this to it, it moves them. Would you please write for me where that one moved? Put it in your notes. It's just an example. Now, there's 3 things there that has happened to it. It was a parabola, but then once you're done writing down the 3 things, I'd like you to write a little number next to each one, like 1, 2, 3, and tell me which one should you have done first, and then second, and then third. That's something that's probably the new stuff for today, is telling you which order you should do these in. I know that you had a little bit of training in that in higher algebra, but not much. Okay, I hope you knew that you're going to be going left 5. There's a little space in there. And that you're going to also be doing a down 6. And the last thing is an up-down flip. Stuff on the outside here. These things are up-down things. So that negative is an up-down flip. So I would say a reflection over, if it's x, up-down is over x, like this. Okay, so what's first, second, and third? Well, let me tell you. You should, there's actually more than one way to do this, but I'm going to tell you a way that I think it'll make sense to you. Do you get how when you have nested parentheses, like parentheses inside parentheses, you start with the ones on the inside? Remember doing that back in the day? The parentheses within parentheses, you start on the inside. How about when we have like f of g of 3? You start with g of 3 first, right? Figure out g of 3, and then you go stick it into the f function. You start on the inside. Let's keep that same tradition. You should start on the inside. So that should be first, and that is first on my list. Number 1. You go left 5. Now, once you're done doing the stuff on the inside, then you do the stuff on the outside. So there's a minus here, and there's a minus 6 there. One of them is a flip, and one of them is a move down 6. Now, which of those should you do first? Well, you follow the order of operations. Remember the order of operations? Please excuse my dear Aunt Sally. Parentheses are supposed to come first. What does this one stand for? Exponents. And then multiply and divide are next, and the last 2 are add and subtract. Just as a reminder, multiply and divide do come before any add or subtracts, but multiplies and divides are tied, just like add and subtracts are tied. For an example, if you had 7 times 7 divided by 2, well, let's change that to divide first and then multiply. Because a lot of kids think, oh, multiply comes before divide. It says so right here. No, that's not supposed to be. Multiply and divide are tied, which means that they have to then be done from left to right. Some people think that multiply always comes first. Other people think it doesn't matter which ones you do first. Wrong. When they're multiply and divide, you have to go from left to right. So I have to do this first, which is 1. And then I have to do that next. 1 times 2 is 2. So the answer should be 2. Well, let's find out. What's 7 times 2? Now, going from left to right, 7 divided by 14 is not 2. It's 1/2. So you'd either have 1/2 or you'd have 2. And the only right answer is 2. So you have to do it in the right order. For add, subtract, same thing. Again, some people think, well, maybe they'll know that add doesn't always come before the subtract. But then they probably think that it doesn't matter. And it does. 7 plus 1 minus 8. Does it matter what order I do that in? Yeah, it does. It does. Okay, if I have plus and minus, I have to go from left to right. Because if I do it that way, 7 plus 1 is 8. 8 minus 8 is what? 0. If I add these together first, it'll be negative 7. 7 plus negative 7 will also be 0. So I just proved that it doesn't matter in this problem. But it does matter. Because you have to know when it's changed to this order. Let's try that one. If I do the plus first here, what do I get? 16. And then I go 7 minus 16, and that would be what? 7 minus 16? Negative 9? Is that right? Okay. And then let's instead try doing this first. What's that make? Negative 1 plus 9, or plus 8, would be negative 7. And that's totally different than negative 9, isn't it? So the point here is you have to do them in the right order. And in this one, you would do from left to right. So it would be negative 1 plus 8 would be negative 7 is the right answer. Did I say that wrong? Positive 7, sorry, positive 7. Got too many boxes around things and stuff. That's first. Once you're done with that, then you do the plus next. And the right answer is 7. It's not negative 9. Okay, so the order of things matters. So back to this. Okay, but, yes? Back to this. Yes, it does. All right, let me, again, I showed you one a second ago where, like, this one, I can do it either way and I get the right answer, right? But yet, do you get that that doesn't mean all problems will work that way? If you want to follow the rules, you got to go from left to right, because sometimes, like in this problem, it matters if you go from left to right or not. So the right way to do it is this way. So the right way to do it is the way I'm going to show you. Sometimes it'll work in any order, and you can do it, and it won't matter. You have to get the right answer. But I need to show you because the ones we pick for the test are usually the ones where the order does matter. You know what I mean? And you might think you've had this way that always works, but it doesn't. So let me just say that this way that I'm showing you will always work. I start on the inside. Once I'm done with that, I go to the outside, and the stuff on the outside I can trust, right? So I can trust the order of operations to be right too. So the order of operations says that multiplies like this right here come before add or subtract like that. So this has to be next, so the reflection should be next, and the last thing is the down 6. So this is the right order. I'll show you more like that, but the key here is start on the inside. Once you're done with that, then you go to the outside and do them in the right order of operations out there. All right, let's look at a more complicated one. Write this one down and put a star by it, because this is the big one. If there was one thing that I needed you to remember from today, it's this. Putting a star by it off to the side tells you later, this was a big one. He wanted us to remember this. I usually have you put stars by things that are important enough you might be tested on them. All right, so write the problem down. The first step is, let's see what order we should do these in. I'm going to do this one with you, so we do it in the right order. And then the next problem, I'm going to have you do it yourself, and we'll see if you get it right. All right, do you get that the first thing I should do is do stuff on the inside? Because that makes sense. It's the same way you do nested parentheses. It's the same way you do functions in functions. You start in the middle. Now, once I'm in there, I have 3 choices. I can do the negative, I can do the 1/2, or I can do the -4. Remember that the stuff on the inside, you can't trust it. It does the opposite of what you'd expect. So it goes in the opposite order of operations. So normally parentheses are first, right? So I don't do this first. I do it last. Normally, I stretch before I flip. That's the stretch and that's the flip. Remember in the gymnastics analogy, it's smart to stretch before you flip, right? So that's the normal order of operations, is stretch before I flip. But since I want to do this in the opposite of normal, I want to flip first before I stretch. So that is my first thing. So first is the flip, and it's a left-right flip. That's over, if I draw my little thing, a left-right goes over the y-axis. So it's a reflection over the y. Yeah. Second thing. Well, it's stretch before you flip normally, so we're going to flip before we stretch. But wait a minute, that's not really a stretch. Or is it a stretch? It is a stretch. On the inside, a half seems like it would make it half as wide. We can't trust on things on the inside, so it makes it stretch twice as wide. Okay, third thing. We're still on the inside. There's only one thing left. What's that? 4 to the right. Some of you are not writing. I'm not going to say your names, but I know who you are. Get writing. You need this one. It's your star example. It's super important. Fourth thing is you're going to go to the outside now. And what should be first on the outside? Well, it's in the normal order of operations. So, is it the multiply by 7 or the multiply by -1? This is two little things, really. Should I stretch before I flip? Yes, I should. That's the normal order of operations. So I should stretch first. 7 times taller. Then flip. Flip is the same as a reflection over. And if it's it's on the outside here. That's going to be an up-down thing. So it's a reflection over the x. And the last thing is that -6 at the end, and that's down 6. Okay, there's your 6 things in the right order. Any questions? Now, is there another way that would have worked in this case? Yes, there is. And I'm going to address that now, even though it might confuse you. But don't do it this way I'm about to tell you, because it doesn't make as much sense. But you can start on the outside, do all the stuff on the outside in the normal order of operations, and then go do all the stuff on the inside. It is true, that will work. But you still have to follow the rule of stuff on the inside goes in the opposite order, and the stuff on the outside goes in the normal order. But I think since you can do it either way, sometimes kids start thinking that means I can do it any way I want to, and that's not right. There's only 2 ways out of a total, there's probably 25 different orders you could put these 6 things in. It's called permutations. You may have learned that in higher algebra too. There's a lot of possible ways you could do it, and there's only 2 right ones. And I recommend you only memorize 1 right way to do it. Start on the inside. That's the way I would be looking for you to answer this. And yes, there's other ways that could have worked. Doesn't mean that anything will work. Start on the inside, do everything in the opposite order, then go to the outside and do everything out there in the normal order of operations. All right, if you really understood that, here's the summary again. I have arrows going to each thing. I'll let you ask any questions that you have, and then I'm going to have you try one. Okay, so there's your star example and stuff you're supposed to have figured out by the end of this day. All right, so one more. Where'd it go? I had another one exactly like that. I must have deleted it somehow. Well then, I'm just going to make another one. It'll be easy. I'm going to go there and go down, and then I'll just erase everything on the screen here. There. And then I'll change these numbers. Let's make that a -8, and let's make this a 4, and let's make this a +2, and let's make this a 0. Okay, try that one. Tell me what order you should do what. First, you should do this. Second, you should do this. This is the kind of thing you'd see on a test. It's not a super hard one. This would probably be an R2. Okay, here we go. Number 1. On the inside, what's first? Which of those 3? The negative. Why? Don't you normally stretch before you flip? It's on the inside, so you do the opposite. So you flip first. And that's a left-right flip. That's also known as a reflection over the y-axis. Number 2. The 4, which is 4 times wider. True or false? False. 4 times narrower, or shrink, factor 4. Number 3. One more thing to do on the inside, and that's the +2. What should I do for that? Left 2. Okay, number 4 is go to the outside, and I got 3 things there. I got a +0, and a -8, and a minus, and an 8. What is first in the order of operations? Well, the negative and the 8 are kind of like tied because they're both multiplies. Of those 2, should you stretch before you flip? Flip before you stretch. Stretch before you flip. So you have an 8 times taller. And number 5, you flip. Flip over, up, down, which is the x-axis. And then the last thing is that +0, and is that really a thing? No, it's not really even a thing. All right, so there's nothing to do there. All right. Raise your hand if you had it right. That's 3/4 of you at least. All right, good. Okay, so there's some practice on those. Here's a typical problem now. They have a parabola and another parabola, and they say, how do you get from the one to the other? Well, people get confused on this because they think, well, doesn't this mean move to the right 7, or sorry, to the left 7? And yes, this one does mean move to the left 7. But if you were here, you wouldn't go to the left 7 to get there, would you? When I say go to the left 7, it means from the origin, like from where it starts, from where the original parent one is. So how do I get from this one to this one? Well, it's really not that bad. You just say, this one's already been moved to the right 5. This one needs to go to the right 7, so you go to the right how far? 2. You go to the right 2. Or is that left? Oh, I was saying right the whole time, and I meant left. I'm sorry. It's left 5 and left 7, so it's left 2 more spots. Do you get how those two, the difference is they got to move 2 spots farther to the left to get there? Okay. And this one, it's down 6. This one's down 10. That means I got to move how much farther? 4 spots down. And the last thing is, the only other difference is this guy right here. So I got to get from this one, to get from this one to this one, I got to move to the left 2 and down 4 and flip it which way? Is that left, right, or up, down? Up, down, flip. All right. Now, which should be first? First, you should go left 2. Second thing you should do, yep, because between this and this, the stuff that's on the outside is a multiply, so it should be next. And the third thing you should do is move it down 4. That's the right order. Okay, let's look at 2 other ones. Here's 2, and this time I'm going to do it by looking at their pictures. Do you get how this red one here is a parabola that's moved 5 to the left and down 6? 5 to the left, 1, 2, 3, 4, 5, and down 6. 1, 2, 3, 4, 5, 6. This one, I couldn't make the dots black for some reason, but it's an upside down parabola. That's the negative thing there. And it is moved to the right 7 and down 4. Right 7, 1, 2, 3, 4, 5, 6, 7, and down 4. Now the net effect then is to get from here to there, I got to move quite a ways to the right, don't I? Well, it kind of makes sense. This one was to the left 5 versus to the right 7, so the difference is what? 12. So I have to move to the right 12 to get from here to here. I got to go right 12. And I can see that on the picture here. So you got to move to the right 12. Then what do I got to do? I have to flip it, and I have to go up 2. Which one comes first? The flipping. And then the up 2. All right. And the up, so flip. And that's a flip on the outside, so it's an up down, so it's over the X. And then it's a difference on this to here of going up 2. And I can see that by this part, going up 2. All right, you get several problems that are like that. I think those are pretty easy ones. Now, problem 35 in the book and 36 in the book, I'm going to preview for you right now before you actually even see problem 35 and 36. They give you this picture, the blue graph, and they say they want you to sketch, if blue thing is f of x, they want you to sketch what would happen if you did this. If you absolute valued the function. Well, what that means is there's 2 parts to a function. There's its x's and its y's. So what I did is I made a little list of all the points for x and y that make up this blue graph. Okay? And if they do this, when they put the absolute values around the f of x, what's f of x the same as? The y's. They're telling you they want you to take all the y values and make them what? Absolute value of that. What's the absolute value of anything turn out to be? Positive. So can you have, when you're done absolute valuing all the y values, you won't have any negative y values anymore. Do you get that? So this part of the graph, here and here, can't be there anymore. Do they disappear? No, they become positive. So those parts of the graph are going to end up here. And up here. So do you see how my new graph would look like that? And why doesn't that have any negative y values? Because we absolute valued all of them. And that turned them all positive. Then you got to figure out what this means. They're absolute valuing all of the x values. So you figure out what that one's going to look like. That means that all the x values get absolute valued, so they have to all become positive. All right, so there's your help on that. I'll leave that up on the board as you start your homework, which is page 147. And it's on my whiteboard, so I'm going to read it for those that are at home. We're doing page 147, problems 18, 21, 24 through 26, 35, 36, and 43 through 49. That's 13 questions, and honestly, this is a pretty easy assignment except for the 2 that I have on the board there. The rest of them I think you're going to find are very easy. So, all right, that's the end of the video for today.